All right, let's dive right in. Today, we're talking about two of the most critical ideas in all of software design, coupling and cohesion. And trust me, these aren't just fancy buzzwords. They're pretty much the secret sauce that decides if a software project is a joy to work on or an absolute nightmare. So, have you ever felt this? You go to fix one tiny little bug, and suddenly three other things that seem totally unrelated just break. It is so frustrating. It feels like you're walking through a minefield, right? Well, that exact problem is what we're going to unpack in this explainer. And the answer, it all comes down to mastering these two golden rules. Okay, to really get this, let's use a powerful analogy. Think of poorly designed software as a glue sculpture. Every single piece is rigidly stuck to every other piece. Sure, it might look impressive at a glance, but the moment you try to change one little part, the whole thing just shatters. Now, on the other hand, well-designed software, that's like a Lego set. Each brick is its own independent functional piece. You can swap them out, you can add new ones, you can rebuild entire sections without wrecking the whole structure. Our goal is to build with Legos, not glue. So how do we actually start building with Legos? Well, it all begins with our very first principle, coupling. And this is all about how the different parts of our software are connected to each other. Let's get a clear definition here. Coupling is the degree of interdependence between software modules. And honestly, that tangled wires analogy is just perfect, isn't it? I mean, if you've got this messy rat's nest of wires where everything is connected to everything else, trying to unplug just one thing is a complete disaster. That's what we call high coupling. What we're aiming for is low coupling. Clean, simple, predictable connections. So, let's really break down this coupling ladder because not all connections are created equal. Down at the very bottom, the absolute worst of the worst is something called content coupling. This is where one module literally reaches inside another one and messes with its internal data. Imagine one Lego brick trying to forcefully change the color of another. It is a huge no-no. It's a recipe for chaos. Now, a step up from that, but still pretty dangerous, is common coupling. This is where a bunch of modules share one big pool of global data. Think of it like a bunch of Lego bricks that all have to share the exact same bucket of paint. If one part of your code changes that paint color, it affects every single brick, often in ways you'd never expect. And finally, at the very top, our goal is data coupling. This is our perfect Lego connection. Modules are independent and they just pass the specific bits of information they need back and forth. It's like handing another builder just the one specific Lego piece they asked for. It's clean, it's predictable, and it's safe. Okay, so coupling is all about the connections between the bricks. Our second principle, cohesion, is all about what's going on inside each individual brick. It asks a really simple question. Does everything in this one piece actually belong together? So what is cohesion really? Well, it's the degree to which all the stuff inside a module works together for a single, well-defined purpose. In other words, if coupling is the tangled wires between components, cohesion is about how neat and tidy things are within one component. High cohesion means a module is focused. It does one thing and it does that one thing well. It's got a clear singular identity. And this comparison just nails it, doesn't it? On the left, you've got the junk drawer, which is the perfect picture of low cohesion. It's a bunch of totally unrelated things, some old batteries, a few rubber bands, a single screw, all just thrown together. In your code, this would be a module that, say, calculates a user's age, formats a currency string, and logs an error. The parts are physically together, but there's no real purpose connecting them. But on the right, you've got the toolbox. This is our ideal of high cohesion. Every single tool in there has a specific job, and it's organized. Need a hammer? You know exactly where to find it. In code, this is a module that only handles database updates, or only processes images. Every single line of code serves that one clear mission. All right, so we have these two really powerful ideas, how things connect and how they're organized on the inside. So now let's put them together and see what the gold standard of software design really looks like. So what is the ultimate goal? It is so simple. We want low coupling and high cohesion. That's it. That's the secret sauce. This is the blueprint for building that perfect Lego set. Each piece, because it has high cohesion, is a perfectly formed single-purpose brick. And the way they all connect, because of low coupling, is simple, standardized, and super flexible. When you build with these two principles in mind, you can create anything you want, and you know it's going to be strong and easy to change later on. And listen, this isn't just theory for a textbook, okay? Sticking to these principles has massive, tangible benefits when you're in the trenches, actually building, fixing, or trying to grow a real software system. So what do you get from low coupling in the real world? Well, for starters, your system becomes incredibly maintainable. You can confidently update one part without that terrifying domino effect of failures we talked about at the beginning. It also means you can build and test different pieces in isolation, which makes development way faster. And crucially, you can scale the system by just adding or replacing modules, just like snapping a new Lego brick into place. And what about high cohesion? Oh man, this is where your life gets so much easier. Our toolbox approach makes your code a joy to read. When you look at a module, you know exactly what it's for because it only does one thing. This is a total game changer for debugging. When a bug does pop up, you know exactly where to look for it. It's contained within that one focused module. And all of this leads to more reliable software because simple, focused components are just way less likely to have errors in the first place. And what happens when we just ignore these rules? Well, we end up right back where we started, with that brittle glue sculpture. High coupling creates a complex, inflexible mess that's nearly impossible to test properly. And low cohesion? That gives you junk drawers all over the place, leading to duplicated code and modules so confusing that nobody can figure out what they're even supposed to do.